my talk will be divided into 3 parts. I will start from telling you what's going to be new for import, then updates for export, and I will finish about telling you how do we integrate our system with FFmpeg library and how you can use it to extend built-in functionalities. All right, so import. So far we had pretty much 2 video formats. It was AVI and QuickTime. We're going to add 4 new formats and also extend the 2 existing formats. On these slides, I'm showing the new lists that we are introducing in 12.1. This is the list of video decoders mainly used for as an information, the kind of read-only list for you to know what's currently supported. So this is divided into formats, and that already tells us what new formats we have. So AVI was there before, Matroska is new, MP4 is new, OGG is new, QuickTime was there before. And there's also called video format. I will speak about this particular one later. So similarly to video decoders, well, actually, let me maybe show you what we have here. So for MP4, so if I go to MP4 section, these are the decoders, built-in decoders that's going to just work out of the box. If you have a video file which was encoded using one of these video codecs, we can successfully decode data from it. For MP4 container. And we have basically the same similar list for other. For Matroska, we can do more than for MP4, for example. So these are video decoders. We have very similar list for audio decoders. Again, we're talking about audio in these video containers. So what I mean by containers is this AVI, Matroska, and so on. You can in this file formats you can store video frames, you can store audio, and you can also store subtitles. And finally the subtitles list looks like that. So only 4 formats support subtitles. AVI, for example, does not allow you to embed subtitle track into the format. Similarly, OGG. Okay, so let's look at what metadata you can read from these video files. We have 2 flavors of the duration of a file. One that we currently call approximate duration, and another one is called duration. The approximate duration, as the name suggests, it's only approximate. So for this case, 231 seconds. But notice the timing. We only need 0.02 second to get it. Then compare it with duration, it takes longer because we really have to decode, well, count the frames basically to give you the exact number. We can read approximate duration from the header, so that's why it's so fast. But to give you the exact duration of the video, unfortunately, we have to do the hard job and decode. Well, yeah, try to decode the frames, but well, don't really return them. We just want a number. So that's what happens. There is a meta information element that tells you more about the video file. So we can go deeper here. There are video tracks, audio tracks, and subtitle tracks for this particular file. So besides the simple container information, that's the container type, again approximate duration, the bitrate. Let's look at the video track. for example, let me evaluate this again. And here are the meta information for each video track. This video has only one video track. So we have frame rate, bit depth, color space, and so on. We also have an information about the codec. So this video was encoded with a H.264 codec, pixel format, and finally the image size. So that's the your video size, right? Of each frame is of the size 764 by 320. All right, and very similar meta information for audio and subtitle. So let me move on. We have also separate elements that give you the number of audio, subtitle, and video track. So in general, you can have multiple of each one of them. Most of the time, you are actually going to have single video track, maybe one or more subtitle track, and usually only one audio track. But as I said, all of them, there could be more than one. And this is the main reason that there wasn't a final review for this yet. But if you look at other import elements related to meta information that we're introducing, we are returning association. So instead of returning how many audio channels is in that MP4 file, instead of returning 2, we're returning association 1 goes to 2. Maybe we may change it. If there is only one audio track, we will just return 2. So that it would be good to get a feedback from you. What do you think? Always return association, even if there is only one track present in the video file, or only if there are multiple tracks, return association. So association always. Okay, so that was all about the metadata. Let's move on to something more interesting, the video elements. So we have a video element for import that gives us the prototype of our video player. This is, again, as I said, this is a prototype, so there are still some glitches, but hopefully you will see and hear something. I guess you don't hear anything. Used to work before. All right, I apologize for that. It's okay. I made it work. Okay, so as you already saw, there is a that button from the audio GUI, right? So you can change the volume and you can select the output audio device. That's the same behavior as we have in our audio GUI. And there is another button here which is inactive for this video, but this will allow you to select subtitle and audio track. So let me show you another video that you can, this will be active. So before I do that, I just want to tell you that video is also a new constructor that we introduced, right? We have image, we have audio as a constructor for the object. Now we're going to have video. And for this video, when I click on this button, there is a way to choose subtitle track. Because if you remember from the previous slide, it had 2 subtitle tracks, right? So if I selected English, it started displaying subtitles in English. So no audio. Well, let me move on. We are experimenting with different appearances of the player. So this is, for example, our experiment with having only the video frames displayed, and on hover you see that you can pause and play. So that's what's coming in this or similar form when it comes to the video player. Now, programmatic playback. That's another interesting functionality, and for that we are introducing a video stream. Again, if you are familiar with audio stream, this is quite similar. With this summary box, you can check some metadata information here. And this is all done out of core, so you notice that this just stores the file path, basically. That's all it is. These are the properties you could already apply on that video stream. And well, one of these properties is called current frame. So here I'm showing you the dynamic of a current frame and the dynamic of a position. And you can control that with functions like video play and video stop. Image list. This element was present before, but we just improve performance and add new efficient access to selected elements, what we call partial import. So first of all, you can select this one means I want a first video track, and then I want a frame 300 to 302. You can do exactly the same using quantities with unit samples, because these are treated as samples. But also you can specify a time range. So say you can specify from 10 seconds to 10.1 seconds. That just, in this case, that just gives me the two frames. What's important is we have to be frame exact if you ask for particular frames. So look at this. I'm asking for the first 50 frames, and it takes only around 0.2 seconds. But when I ask for the last 50 frames of this video, it's almost 7 seconds to return. You asked for that. You asked for the exact frames. I have to decode the whole file to get you the last 50 frames. So that's why it's not linear access. If you're asking for something from the end, we really have to decode up to this point. However, if you don't care about the exact frames, you can use the specification in seconds, in time range. And if you do that, we guarantee only millisecond accuracy, and we can easily seek to that millisecond position in the video frame, and it's basically the same time, whether you ask for the first 5 seconds or the last 5 seconds. That was image list. Video data works very similar, and we are returning numeric arrays that correspond to image frames. And finally, you can ask for a duration of each frame, and the partial access is again the same. Moving on to audio elements. So we also introduce audio import element, and it works similarly. You can ask for samples, or you can use time quantities to get partial partial access for audio. Some formats we also support audio file, which is our out-of-core audio representation. But then obviously there is no partial access. You basically giving you access to the whole file, but it's out of core, so it does not take any memory. And finally, similarly to video data, you can get audio data, if only that opens. Well, then let me move on. It's also retros numeric array, basically, for audio data. Subtitle elements. Currently, let's consider that this is the first release. We only introduced the raw subtitles in a particular format. It's called Advanced Substation Alpha format. It's kind of divided into two categories. First, you get a header data. So that's how the header in this particular format looks like. It kind of defines the style of the subtitles and the format of the events. And now the actual text data look like that. So it's slightly pre-processed, but other than that, you see that this is quite raw still. You have to understand what this is. And the description of what that text really means is here. That's the format. So you have layer, start, end, style, and so on. That corresponds to this line. Okay, I said that I will go back to the video format. So what is video format? It's something that you can use when your video is not in the other format that we support. So say you have a TS video. Then, well, there is a good chance that it's going to be support out of the box. We actually register a bunch of extensions. So we also registered that TS is associated with video format. So you don't even need to specify that you want to import this as a video format. It will just recognize it. Unless we don't register an extension, you should still try to force the format, video format, and there is a good chance you're gonna be able to import the information. This is import-only format. So it supports many different video formats, less common video containers. We decided to basically put everything in one format. So as you can see, I can import the default element here for import is a video stream. I can also import the audio data. It all works, but this is import only. Okay, so that's all about import. Let me now talk a little bit about export. For export, we're adding 3 new formats. We're not adding video format, right? So this is not symmetric. And we're extending the existing 2, that is AVI and QuickTime. Similarly to import, we also have this $list for encoders, and these are actually more useful because you can use them as the values for video encoding and audio encoding options for export, right? So say you want to use generate MP4 file and you want to use say VP9 codec, then you have to specify video encoding goes to libvpx-vp9, and this will generate MP4 file encoded with VP9 codec, and same for the audio. Supported formats. So now let me start from showing you how to export video frames only to a different file format. So first of all, given the manipulate expression, we can rasterize the manipulate, get a list of frames, and then export that to a video. because I don't have much time left, I'm just going to show you the final result. Right, that's the MP4 file that I generated from that manipulate. I can do the same thing for image list. So I've imported multi-frame TIFF file and basically exported list to MP4, list of frames. Also video and video stream. So if you import video object or video stream, you can pass it directly to export, and again, it will work. And what's nice about it is it's all going to work out of core. You have to have enough memory to store this list of frames that you want to export. But if you already have video or video stream, which is out of core, you can convert it to a different format using export, and it really doesn't use any of the memory. It's all done in the background using out of core functionality. Okay, you can finally do video plus audio into a single file. It was not possible before. So say we have the same manipulate, but I'm going to generate the 2-second long audio using audio generator. And then using this syntax, so I'm specifying that my animation is my manipulate, my audio is the audio that I just generate. I have to use that rules syntax for export, and I'm specifying some more options for how to convert manipulate to list of images, and then it will just work. It's going to generate something like that, and it does have audio. It's a pity that I cannot really show it. Yeah, it doesn't work. Okay, and finally, obviously, you can also export list of images. So what I'm showing here, I'm taking this 6 seconds long list of frames from that movie, and I'm also extracting the same corresponding audio, and then exporting these two objects to a video, and again I'm getting 6 seconds long audio video with that audio. And finally, you are free to export only audio to these containers. They are the multimedia containers. You can store 3 different type of tracks, but there is we don't prevent from exporting only audio to these formats. I want to mention quickly about the FileConvert function. So that's the nice utility that allows you to convert, or what we call it here, it's transcode one video from one format to the other using default setting. Right now, we do not really allow you to do some fine-tuning. If you really want a fine-tuning, then go from import followed by export. Then you can use all the options. But here, using the default setting, it's gonna do. Let me just evaluate this and show you. It should not take longer than 30 seconds or so to convert this MP4 file to Matroska. And it's all working out of core. So it basically uses the default element of import, which is in this case video stream, out of core object, and then passes it to export using default settings, and that finished. And we now have the video in a different format. All right, so the last section I want to talk about here is the limitations and what you can do about this. So you, as you already know, we use it as a backend, the FFmpeg library. So all of I just showed you here it was possible using the FFmpeg as a backend. We also use different backends, that is Media Foundation on Windows and AV Foundation on macOS. However, even with that, well, because some codecs are patented, we had to disable them. So we cannot really ship them with Mathematica. And there are videos out there that you won't be able to import. That's one of the example. I have the excerpt from the Harry Potter movie in the Matroska format here. It says that it's H.264 codec. Well, to show you something, if I try to open this in QuickTime, it's going to tell me this. So we're not worse than the operating system, right? The operating system also cannot handle that file. And well, going back to that list of video decoders, so I showed you before, we have this number, you probably don't see it, it's 54 entries in this data set. Right now, these are the list of decoders that we support out of the box for Matroska. However, if you have FFmpeg installed on your system, and you can do that. Right now we're experimenting only with Linux and macOS. So on Ubuntu, just call this line, more or less, and it should give you FFmpeg on your system. On macOS, we support Homebrew. So just that line should install FFmpeg for you. And once it's installed, we will try to use it without even asking you. It's just, if it's possible for us to load it successfully, we will do this by default. And there is actually a setting for that. You can disable this behavior using that system option. But what I did is, hopefully it's going to work. So now I'm trying to use system FFmpeg, which I already have installed. There was 54 decoders available. Right now I have 237. And when I try to play this file, now it works, right? Because it's using everything that FFmpeg offers you. All the codecs out there are now enabled. All right, I think that's it. I just want to mention that there are two other talks this afternoon on video, right? The one that Shad is going to speak in a few minutes, and then there is video processing analysis talk. Do you have any questions?
Can you put that last slide back up?
Sure. Yep.
So question, can you also set the bit rates when encoding and transcoding and things like that?
Well, we have a, yeah, I didn't really have time to talk about this. We have a compression level option for export, which is basically converted to a bit rate. But yeah, it's just 0, 1.
And for export, will it be like also an equivalent of like binary write that you can do subsequent, you know, you put a frame and then another frame and another frame? So you have
Right,
50,000 frames,
yes.
you can't do it in memory anymore, right?
Well, right. So you can actually do something like that with video stream. There is a current frame that you can access from video stream, and then, well, the question is, how do you write this, right? I mean, you can read frame by frame using video stream. We do not have a functionality right now with export that allows you to basically open the stream and write to the stream. Obviously it's available in our internal functions. We have to think about this, but probably there should be a dedicated feature for that. We should not extend export because that's like one shot right now. That's not a function that should, yes. Okay, I don't think we have time for more questions, so you can ask me later. Thank you very much.